At the end of this video, I'm going to ask you to write down all your shiny new knowledge about metamorphic rocks and compare it to what you knew only a few short minutes ago. Let's dive in. So metamorphism takes an existing rock, for example, a granite, and turns it into a whole new rock, for example, a gneiss. And it does this by applying temperature or pressure. There's so much information that geologists can mine from metamorphic rocks. And these include the temperature and pressure from which the metamorphic rock was formed, which helps a geologist put together what we call a geological history, from what happens in the area, from plate tectonics to igneous intrusions to lots of sediment deposition. It encompasses the whole geology. Changes in the temperature and pressure moves a rock from what we'd call a stable environment, so one in which the minerals are happy to stay as they are, into an unstable environment, which means the minerals want to change. And that can be a change in structure or a change in composition. A change in structure can result in foliations. So for example, you can see in this rock, there are lines in it. So these minerals in your granite have changed the orientation to align with the pressure that's been put on them. There are three types of metamorphism. This is contact, regional, and dynamic metamorphism. Now contact, as the name would suggest, is when something comes into contact with the country rock. And what do I mean by country rock? It simply means the rock that is existing there. So that could be igneous, sedimentary, or metamorphic rock. And what do I mean by something coming in contact? Well, igneous bodies such as magma intrude into the country rock, and this creates an immense amount of heat surrounding the body. And what this does, it cooks the margin of this intrusion. And that would change the composition of the rocks around it. So a rock that you might be quite familiar with that's made through contact metamorphism is marble. And that is from an igneous rock intruding into limestone, cooking the limestone around it and changing not so much the composition, as it's still the same chemical composition, but the structure of the minerals within it. And this is done all without melting the rock. So a second type of metamorphism is called regional metamorphism. And this type of metamorphism occurs when things are buried deep within the crust, and it increases the pressure. So you can imagine if you have a mineral sticking up like this, if you put a lot of pressure on top of it, it's going to slowly reorientate. And that's where you get a lovely foliation. And we'll talk about that in a little bit. As a general rule, the shallower you are in the crust, the lower grade regional metamorphism it undergoes. Whereas the deeper you get, therefore the higher pressure, the higher grade regional metamorphism you get. Dynamic metamorphism is quite different from the other two. It happens along fault lines. So these are areas of very high pressure, but virtually no temperature change, which is quite interesting. So the rocks along these actually end up being quite brittle compared to other metamorphic rocks. And we'll look at some of those later. These four are examples of regional metamorphic rocks, going from order of lowest grade regional metamorphic rock to highest grade rock. And by grade, I just mean the degree of metamorphism it has undergone. You can see in this rock that the foliations, and by that I mean the structure of alignment of the minerals, is not as pronounced as this rock. You can clearly see the banded formation of minerals. So these rocks have a non-foliated texture. So you can clearly see that we don't have the lines in the rocks as we did with our regional metamorphic rocks. So these are our contact metamorphic rocks, this one being marble and this one being quartzite. Marble is created by contact metamorphism of limestone, whereas quartzite is created by contact metamorphism of sandstone. So dynamic metamorphic rocks, they have a texture that range from an angular, shattered rock fragments to very fine or granulated powder. Now these rock types don't have any obvious foliations or lineations, and that's because they're created very quickly in high pressure environments such as faults. So in conclusion, metamorphic rocks are those which have changed from an existing rock to a new rock due to applied heat or pressure. There are three main types of metamorphism, all with varying degrees of the supplied heat and pressure. These three types, as you know, are contact, regional, and dynamic metamorphism. At the start of the video, I asked you to write down everything you knew about metamorphic rocks and the processes that form them. It's now at the end of the video, so it's time to compare what you know now to what you knew only a few short minutes ago. When you compare your lists, maybe you can think about how your understanding of metamorphism has undergone a metamorphosis.